Okay, kids, this is day four of our review for our final exam. So just listen to this video. You don't really have to do all the work. I just want you to kind of listen to see what we're doing to make sure you have an opportunity to do the best you can on your final. So Charles found a t-shirt for $12. It was marked 20% off. How much will he save on this shirt, and how much will his shirt or t-shirt cost after being taxed at 6%? Alright, so all mathematical thinking. So we got the cost of the shirt. That's $12. And it was marked down a certain percent. So it was marked down 20%. Okay, the decimal we move over twice. So when we move it over 20%, it just moves from here and goes over. And that's where we get our 0.20. Our tax percent is 6%. And that looks like 0.06. We move over the decimal twice and we get that 0 in there. Okay, so the expression to find the discount, well, our t-shirt is $12. Our discount is times 0.20. And so the amount of the discount was $2.40. 12 times 0.2. The expression to find 12 times 0.2 is 4 and 2 and only one decimal. Right, the expression to find the tax. Right, so the expression to find the tax is going to be the cost of the t-shirt, right, minus the discount, all times 6%. Or 12 minus 240 times 6%, or 9.6 times 0.06, which equals 58 cents, or 0.58. Right, and so that was the amount of tax. And so the total cost, when we go back to find the total cost, we don't use the 12, right? We do not use the 12. We use the 960, right? And we go back and we put in the taxes. Because when we pay taxes, we have to add it to our final cost, or the total cost. And so that's 8, 11, 1, and 10. So that's total of $10. So $10.18. Number 2, it says Josh borrowed $4,850 at a simple interest rate of 4.5% for 5 years. Okay, so how much did he borrow? He borrowed $4,850. His rate was 4.5%, which if we change that to a decimal is 0.045. And his time, we always put time in years, right? And so that's 5 years. And this is our formula we're going to use. So we're looking for interest, right? And so we're going to take principal, multiply it times the rate, and multiply that times 5 years. And we get $1,900. I'm sorry, $1,091.25. So $1,091.25. So that's the amount of interest, $1,091.25. And so our total amount paid, well, we're going to take the amount that we borrowed and add the amount of interest back to that. And that gives us a total amount of $5,941.25. Number 3, Josh found a video game that was originally priced at $75. It was on sale for $60. What was the percent of change? Percent of change on the price of the video game. So the percent of change looks like this. 75 is the original minus the new all over the original cost. And so we get 15 over 75. And if we break that down, we can divide by 3, and that equals 5 over 25. And that equals 100 and x. So x over 100. So how did I get from 25 to 100? Well, I multiplied times 4. So I'm going to multiply this times 4. And that's going to give me 20%. Alright, I promise I did not skip number 4. Just when I made this review, I accidentally put 5 instead of 4 in. Not a big deal. Number 5. Kate bought a book for $14.95, a record for $5.85, and a tape for $9.70. If the sales tax on these items is 6.5% and all 3 items were taxable, choose the expression that would find the total amount she must pay for the 3 items. Alright, so let's look at letter A. Alright, so if I do this, right, I'm actually buying 3 of these, 3 of these, and 3 of these. Okay, I only bought 3 items. Well, that gives me 9 items, so it cannot be A. And also, this is not the right percentage anyway, because it's 6.5%, and so that looks like that, 0.065. So the same thing is wrong with letter C. Alright, so if I go over to B, I'm looking at the same thing. I'm buying 3 of these, 3 of these, 3 of these. This is what that 3 does. It multiplies by all of those. So I don't want to do that. Alright, so I would say B is out as well. So let's look at D. Well, if I add all these up, right, and I multiply times 0.065 and add that back to the original, right, which is what all this is, then I will get my correct answer. Because I'll multiply these 2 together, these 2 together, and add it back to the original right here, right? And that will give me my answer. So I'm going to choose D. Alright, number 6. Number 6, I really like this problem. Kids really have a hard time finding percent correct on tests and percent correct on quiz. But Matt got 20 out of 25 questions correct on his last test. So if I'm looking at the test, I got 20 out of 25. Right? And if I want to change that to percent, I just have to get to 100. How do I get to 100? I multiply times 4, so here I would just multiply times 4, and that would give me 80%. Now on my quiz, I got 17 out of 20 right. So I'm going to do 17 out of 20, right? And, well, I want to get to 100 again for percent. So how do I get from 20 to 100? I multiply by 5. So I'm going to multiply 17 times 5, which is 85%. And so now I have 2 percentages that actually changed. One went from 80, and it went from 80 to 85. So I really had a 5% change. Okay, so the change in, not price, but the change in percentage, right, was 5%, right? And then that's over my original, which is 80%. It's 5% over 80%. So 5 divided by 80, or and I can reduce this down, right? So I'm looking for a percent, but basically I'm doing 5 divided by 80, which is giving me 0.0625, and as a percent, I would move the decimal over twice, so it would actually be 6.25%. Number 7, in class, Diane correctly drew the bar diagram below to model a problem. Which problem was Diane modeling? Well, let's look. It says A customer paid $12 out of a cost of $30. No, I'm looking at a percent of 30, not a cost. What percent of cost did she pay? So I would say that this does not add up to what they gave us as far as the bar diagram. B, a customer saved 30% off of a t-shirt. So there's the 30%, right? Off a t-shirt, a $12 shirt. Okay, well, if I had a $12 shirt, then that would be the total cost down here. And if I saved 30%, then each one of these would have 1.2 in it. And that would not be the correct choice either, because that only adds up to 3.6. So that's not the correct answer as well. So a customer paid $12, right? I agree with that. This was 30% of the total cost of the item. All right, so if I think about this, well, if there's 3 spaces, that means there would be 4 in each one. And so 4 times 10 would be original cost of $40, right? And I did save 30% off the cost, which is here. So I would agree that it would be C. Let's prove D wrong. The customer paid $12. They should pay 30% more of the cost. That would be a markup. Okay, and there's nothing on here to indicate markup. So I say D would be wrong, or not the correct choice. Number 8, we're talking about interest again, right? And I have a principal, rate, and time. So I have a loan of $45,580. So that's my loan, $45,580. This loan has a simple interest rate of 4%. Well, I have 4%, but that looks like that as far as a decimal, right? Per year. How many years? 1. So what is the amount of interest that Rita will be charged? So if I put the principal and the rate and the time all together, I get 45,580 times 0.04, because I changed it to a decimal, times 1. And that is equal to $3,646.40. So I would choose D. Okay, they're not looking for the total cost, right? They're looking for what the interest would be. This is my I. Number 9, Leo wants to buy some shoes, right? He found the shoes at 3 different stores for an original price of $35. But each store is having a sale. I should say each store. We're not going to worry about that though. Alright, so store X is offering 50% off the price of the shoes. Well, how much is 15% off of 35? Well, 10% is 3.5. 3.5, and then I would do another 5%, so that would be half of 3.5, which is 1.75, and I add those together, I get 5.25. So basically, I'm going to get 5.25 off of $35. Store Y is offering a $5 off, right? And then store Z is offering 1/5 or 20% of $35. Well, 10% is $3.50, and so another 10 would be another $3.50, and we add that together, and that gives me $7. So I don't really need to know the sales price. I don't need to know this information because I know how much I'm going to get off for each one, and it's the same price that I started with. So which store has the best sales price? Well, it's going to be the one that has the best sale, which is here. All right, so I would actually pay $28 for store C. So I would pick store C. stored C, which is answer C. All right, number 10, Zion plans to run 14 laps around a track. Each lap is 400 yards. So far, Zion has run 1,680 yards around the track. What percentage of the run has Zion completed? Okay, well, her total yards, right, we're going to do 14 times 400, and that gives us 5,600. So total yards is 5,600, and she's run 1,680. All right, so we just basically need to break that down. 1,680 and 5,600. So I can immediately take off the zeros, and I would just divide by 2 on each. So divided by 2 divided by 2, and I get 84 over 280. And I'm just going to keep going. So I'm going to divide by 2, and I get 42 over 140. 42 over 140, that's going to be 21 over 7. And I can divide both of these by 7, and I get 3 over 10, which is 30%. So I would choose letter C. Number 11 is a little bit more difficult because we actually know what the interest is. We actually know what I is, right? And for each year, so we know that that's a year, and our principal was 1,800. But if we set this up in the formula, we know that it was 54, and that equals to the principal times some rate times 1, which is time. Right? Now, how do I get R? How do I get the rate by itself? Well, I know that 1,800 times 1, right? 1,800 times 1, well, that's 1,800. So I have 1,800 R is equal to 54. Right? Trying to teach the kids, a lot of them are starting to get it now, but how do I isolate the R? I have to do the opposite of what's happening. It's being multiplied to the R, the 1,800 is, so I'm going to divide both sides by 1,800. And when I divide 54 divided by 1,800, I put the 54 inside and the 1,800 outside. So how do I get this? Well, I have to add a 0, and that does only 540, so I have to add another 0. Okay, and so 1,800 goes into 5,400 3 times. And so I would get 0.03, which is, if I moved 0.03 over twice, 1, 2, right? Oh, I apologize. I'm moving the decimal this way. So I'm moving the decimal this way. 1, 2, that ends up with 3%. And that is answer A. Number 13. Still having a lot of trouble with these, so I would definitely practice a couple of these problems over the weekend. Right? But if I have a negative 9 equals 3/4 x plus 3, the first thing I could do to get rid of this 4 is I'm trying to teach the kids to go ahead and multiply everything times 4. So we're going to multiply this times 4, the 3 times 4, and the other 3 times 4. And that's going to give me a negative 36 is equal to 3, because the 4's cancel each other out, x plus 12. And so now I have an easier inequality to fool with. All right, so my next step is to take away the easiest thing. Is it easier to take away multiplication or addition and subtraction? I would say addition and subtraction. So we're going to subtract negative 12 from both sides. When I subtract two negatives, I get a negative. And I add the negatives together. So actually I get a negative 48 is equal to, this goes away, and I get 3x. I can isolate everything by drawing lines down. That way I keep everything in order. So now I have a negative 48. Negative 48 is equal to 3x. How do I get rid of multiplication? I do the opposite. So I divide both sides by 3, and I get negative 16 is equal to x. Number 14. Right, this little guy is a negative 2 right here. He belongs to this whole thing. All right, and so a lot of kids are starting with the negative 1 and subtracting it out, but we really got to get rid of that negative 2 first. How do I get rid of negative 2? If I'm multiplying negative 2 times something, then I'm going to divide the negative 2 out. So when I divide the negative 2 out, that changes my sign. So divide by negative 2 changes the sign. And so now I have a greater than or equal to. And 10 divided by negative 2 is negative 5. Right? And then I can isolate this down. This goes away. And now I have 3x plus 1 is greater than or equal to a negative 5. Well, my next step is to get rid of the simplest thing, the easiest part, which is the opposite of addition and subtraction. So I'm going to subtract both sides by negative 1. And then I end up with a 3x is greater than or equal to, that doesn't change the sign, it stays the same, negative 6. Next thing I do is do the inverse of multiplication, which is division, and I get x is greater than or equal to a negative 2. So when I go back to graph that, I just go to negative 2, put a circle and fill it in, and then greater than. Number 15. All right, this really stumped a lot of kids, but the main thing you got to understand about reading this part over here is that this whole thing right here is equal to 19. So the ones that have equal to 19 are the ones I'm looking at. If it doesn't say equal to 19, I'm not even going to try to look at that. So now we got to say, well, what is in between these two? Well, there's a plus sign. It says 4y plus 7 is equal to 19. So which one of my letters say 4y plus 7? It would be A. And this is actually supposed to be C. But A would be my choice. Number 16, solve for the value of x. We have a triangle. All triangles, angles, equal, when you add them all up, 180 degrees. Right, so I have 25 x's plus 11 x's plus 9 x's. And so I don't subtract the 25 or subtract the 11 or subtract the 9 to the other side. I add up all my x's. So I now have 25 plus 11, which is 36, and then I add 9 to that. So I have 45 x's, and it equals 180 degrees. How do I get rid of a multiplication? I do the inverse or opposite and divide by 45. And that leaves me with this information going away. I'm left with an x, and it equals, and 180 divided by 4, I'll put the 180 inside, 45 on the outside, and that would be 4. 4 times 5 is 20, 4 times 4 is 16, plus 2 is 18. So my answer is 4. Number 17. Okay, we have 8 plus 0.75d is equal to, first thing I do is subtract 8 from both sides. I get 9. This goes away, 0.75d is equal to, well, I have to divide by 0.75, right? And so 9 divided by 0.75. Move the decimal over twice, so my decimal is actually down here now, and I have 2 zeros there. So 75 goes into 91 times. Subtract that out, bring the 0 down. 75 goes into 150 twice. So x is equal to 12. Now Ray T says which value does not make the inequality for you. So let's just solve the inequality. So I subtract 5 from both sides, I get 3x is less than or equal to 9. So what makes this true? Well, x is less than or equal to 3. So if it's less than or equal to 3, 4 can't be a solution. The numbered line represents the solution to which situation? Well, I'm going to take the 40 students and put them back into my equation that I create. Right? So 20 plus $1.50x, or times 40, right? So 20 plus 1.5 times 40 is equal to 20 plus 60, which is equal to 80. A lot of kids ask, well, which way does the arrow go? It doesn't matter in this equation. They want to know if you know how to plug numbers back into the equation to solve for x. So that's putting the 40 back into your inequality or your equation. So my answer would be A. Okay, this one really got a lot of kids. But if you look about it, isosceles mean that you have two angles that are the same, right? And the tick marks tell you which angles they are. This tick mark points to this angle, and this tick mark points to this angle. Okay, so angle C is actually 3x plus 10 as well. Right, so when I go to add everything up, 2x plus 3x plus 10 plus 3x plus 10 is equal to 180. So I got 3x plus 2x plus 3x, so that's 8x, and then I got 10 plus 10, which is 20, is equal to 180. I'm going to subtract. The easiest thing to do is subtract from both sides, so that gives me 160. And I bring down my 8x. So now I have 8x is equal to 160. I do the inverse, or divide by 8, and I get x is equal to 20. A lot of kids stopped right there. They didn't ask me what x was. It asked me what angle C was. Okay, so I have to take the 20 and put it back into my equation. Right, and so 3 times 20 is 60, plus 10 is 70 degrees. All right, so we got a theater that started with $50, and they had $8 per ticket, and that equals to $1,450 what they have. So I subtract 50 from both sides, and I get 8x is equal to 1,400. Well, I divide both sides, or take the inverse, and I get 1,400 divided by 8, and that gives me an actual 175. Well, I needed to buy 200 tickets, so I'm going to take the 200 and subtract the 175, and that gives me 20. Denise has prepaid cell phone this month, right? She wants to buy a $9 plan at 10 cents per minute, and she wants to keep it under $45. Well, my first thing is to get rid of the 9, right? So that goes away. This goes down to 10 is less than or equal to 36. I'm going to divide both sides by 0.10, or 10 cents, and I get x is less than or equal to 360. lot of kids stop there, right? But that's 360 minutes, right? How many hours is that? That would be 6 hours, which is 6 times 60 per minute, or 60 minutes, which is 360 minutes. All right, 24, right? We got a situation where we're just putting these values back in, right, and see what they do. So the 10 would go up here, right, and 10 over 6 is some crazy number, right, and minus 5. But what minus 5 is equal to a negative 3? Well, actually, that would be 2 minus 5 is equal to a negative 3, right? And so I got to find something that gives me a solution of 2. Well, the 10 didn't work, so I'm going to try the 12. Well, 12 divided by 6 is equal to 2, and 2 minus 5 is equal to 3. So I'm going to pick Lisa. A lot of kids got that one right. All right, last problem is 25. Okay, what situation can be represented by the equation 40x plus 20 is equal to 200? Well, if I do this, 200, and then Mitch borrowed $20 more, right? So that means he actually owes $220. Okay, so he owes 220. But if I subtract this away, Mitch only really owes 180 because he's already paid $20. So Mitch owed Jason $20, so Mitch already paid Jason back $20. So that's where that came from. So my answer would be B.